Alright, so in this video I'm just going to introduce the situation where we're looking for creating an interval estimate for a population mean when we don't know sigma, the standard deviation of the population. So the process is the same as when the standard deviation is known, except now there's a couple differences. One, we don't know sigma, so we have to estimate it from the sample, so that's just S, the sample standard deviation. So we estimate using the sample, the standard deviation, we get the sample standard deviation, and we plug that in for the population standard deviation sigma. We also use the t-distribution instead of the standard normal distribution. So the t-distribution is similar to a standard normal, except its shape is less peakier. So let's have a look at this. So this is the top curve here, the top distribution. It's the black curve. It is a standard normal, and then the blue and then the green are t-distributions. So one thing is that the t-distribution, it's actually a family of distributions, and it depends on a parameter called the degrees of freedom. So the t-distribution, like I said, it's a family of probability distributions where each one has a different shape depending on a parameter called the degrees of freedom, which is equal to n minus 1. So df, degrees of freedom, is equal to n minus 1. So basically what this is saying is that your sample size is going to affect your t-distribution. So let's think about this for a little bit. What this is telling us. So if we look at this, the t-distribution with 10 degrees of freedom, right, it's less peakier. So what happens is, remember, the area under the curve has to stay 1. So if we're squishing down the top part of the curve, what happens is more area gets pushed out into the tail. So if you look at the tails, right, this one right here, this black one, this bottom one, is the standard normal. And then we have the blue and the red one. Their tails are what we call fatter. There's more area under here, under these curves. And so let's see, this middle one is or let's go with the top. This top one right here is 10 degrees of freedom, so that's a sample size of 11. And then 20 degrees of freedom, that's a sample size of 21. So we see as our sample size actually gets bigger, the area under the curve gets less, and actually the distribution approaches a standard normal distribution. So why is that the case? So why are we now using a different distribution, and why is it related to sample size? We'll think about it. We are now going from saying, hey, in previous example, we know the standard deviation. Well, now we don't. So when we don't know the population standard deviation, we have to estimate it from our sample. What happens? We're introducing uncertainty. So when we're introducing uncertainty, that affects our probability estimates. And in fact, now what happens is that because our tails are getting fatter, we're basically saying that we're not as sure that there's whatever value or parameter or whatever we're interested in is concentrated here. We're saying that there's actually higher probabilities that it's somewhere in the tail. So that's what's happening, why we have to use these distributions, why they're related to sample size. Because as sample size increases, right, what's happening to our distribution? It's shaping, it's approaching more the standard normal, and then the area under the curve for those is less. So that's why we now have to use the t-distribution instead of the standard normal. And how and why it's related to our sample size. So if we look at this formula for creating the interval estimate, it still is the same, or it's similar. It's not the same. It's very similar to when we didn't, or when we did know sigma. Now we don't know it. So what's the difference? We still have the point estimate. We're still adding and subtracting the margin of error, but now instead of using sigma, right, the known standard deviation for the population, we estimate it from the sample. Also, instead of having, remember, we used to have z, now we have t, which is saying that, hey, we're not using the normal distribution anymore, the standard normal, we're using the t-distribution. S, we've already learned the sample standard deviation formula. It's right here in case you forgot it, but remember, we've already learned how to calculate that. So in the next video, we're going to actually do an example where we create an interval estimate when we don't know sigma.